Good morning, everyone. We are about to discuss process selection, analysis, and design. And I am here to discuss the four types of processes. First, we have project. It is a product or service-based production system. The order must be completed at each given time and at an exact cost. The example of these are construction of airports, roads, dams, and building. Second, we have job shop production. It is the small amount variety of products produced, and each item have their own processing routes and different parts. For example, we have 100 units green colored bottles, 150 units of black colored bottles, and 100 units of red colored bottles. As we can see, they have different production line running separately and they producing different products. Third, we have flow shop production. It is the repetitive continuous task. The example of these are cars and appliances. And lastly, we have continuous production process. This type of production process is continuous by 24 hours, 7 days a week, and a day all a year. The example of these are oil, gas, and petroleum refineries and other chemical processes.
The three types of goods and services. First is the custom or make-to-order goods and services. These are generally produced and delivered as one of a kind or in a small quantities and are designed to meet specific customer specifications. This product begins to produce or manufacture only after the confirmed customer order is received. For example, is the customized salad set, ordered cooked foods for different occasions, or printed t-shirts with personal designs. Second is the option or assemble to order and services are these are configurations of standard parts, sub-assembles, or services that can be selected by customers from a limited set. These products or services are also ordered by the customer that is served or produced quickly. These are parts of the products that are already manufactured but not yet assembled or services that have different set of offers. For example, is purchasing a PC. Then the finished goods such as monitors, CPU, mouse, keyboard are combined from different operations to make a final product. Then lastly is the standard or make to stock goods and services. These are made according to a fixed design and the customer has no options from which to choose. These goods and services are made and served based on the consumer's demand. In other hand, these goods and services are stocked for future sales that have not yet taken place at the time of production. For example, is the ready-to-purchase goods such as soaps, beauty products in all supermarkets.
Let's talk about service matrix. The service encounter all the process steps to fulfill the customer's wants and needs. There are two types of services. First is customers routed services, which means that the customers have freedom to select the best for their needs and wants, and the customers will decide what path to take through service delivery system with only minimal guidance from the management. It means that customer can select based on his or her preference and immediate needs. For example, ordering online, visiting museum, and going to amusement park. Second is providers routed services. It constrains the flow of customers through some predefined services only. For example, ATM and online banking account.
Value stream mapping is like taking an aerial shot to the whole organization or business. Why? How can we say so? It is simply because value stream map shows the whole situation, the whole process of the production of a certain business. Because of it, you are able to find what the problem within the process of the production of your products. And of course, you are able to find what is the best solution for it. Also, value stream mapping highlighted the value-added activities and non-value-added activities. When we say value-added activities, these are the activities that the customers are willing to pay because it was included to what you are being offered. For example, the entering of orders, the packaging of your product, and of course, the shipping for the customers. These are the examples of value-added activities. On the other hand, non-value-added activities, these are activities wherein your customers are not willing to pay for it. For example, the inspection of your products, the process delays, and also the paperwork where it is done by your management. And these two activities are usually observed during the value stream mapping. To better understand what value stream mapping is and how can we apply those theoretical knowledge that we had, let's take an example. Imagine that there was a coffee shop that every day they lose a customer. So, in other words, they badly need an improvement about their process because their customers are not getting satisfied anymore. In this situation, value stream mapping is really a great help for them because they were able to find what the problem is and they can conclude to a better solution. To know the problem, you wish the process on how they make coffee, and they say these things. First is order coffee. Second process is the payment process. Third is the make coffee. And fourth is hand coffee to customer. So as we analyze about their process, we think that it is very simple. But what is the problem about it? So let's elaborate it. According to the manager, they observe their customers way too much time before they handed their coffee. And customers can't locate the counter easily. Also, the mode of payment of the coffee shop is only available through cash. And there are times that they have a wrong input in the system of what the customers really ordered. After knowing the problem of the coffee shop, you explain to the manager that he or she need to record the waiting time, the processing time, and also the error rate they made in every process they made. So now, imagine that he gave you the data that is highlighted with the yellow. You observe that the process of making coffee have the greatest time consumed and customer payment process has an error rate of 30%. So now, we can conclude that the 12 to 20 minutes was spent by waiting of the customers and 7 minutes for the processing of making coffee and 30% is an error in every process they made. With that conclusion, this value stream map will now help the manager of the coffee shop to think what is the better action they can make or what will be their action to make an improvement about their business.
One of our objectives in this topic is knowing how to improve process designs and analyzing process maps. In improving process designs, we need to identify our problem or where the part of the process design is needed to be improved. A feedback from customer is also important since we can base their opinions or suggestions in improving our process designs. Also, after doing it, we need to do a value stream map. Value stream map needs to be specific, means we need to input or we need to put what are the techniques, the strategies, the technologies and equipments that we will use. After that, we can create evaluations or we can do some short testings or hypotheses for the further continuous of our process designs as well as for its development and improvement. And when it comes to analyzing process maps, we need to utilize more tools and find more approaches, techniques, and do some further researches that will make our process design more effective and efficient. Also, it is very important to become specific in finding the techniques or tools so that it won't be time consuming when it comes to analyzing process maps.
Okay, so now let's talk about little law. So what is little law and what it is for? Okay, so little law is used for rough calculations, predictions, and process analysis. It also track performance over time and uh, even make your plans change in a business. It uh it also stood the test of time when providing a powerful tool used in examining the queuing system. So, it is also a theorem that determines the average number of items in a queuing system. So, in a simple explanation, little law helps a particular business to calculate how much uh, average items can be in a queuing system. So that average items are represents people. And the queuing system is from the word queue, which means a line of a line of people waiting for their turn. So example here is you went to the Jollibee. So for you to order and eat, you have to go in line. So in a line, uh, there are 10 people and you are the ninth. So in queuing system, related to the little law, it it is used to calculate in a per people how much time they spent to wait until it, it is their turns. Okay, that is it. So let's go to the formula. So formula here is L equals the A symbol times W. So it is the A-like symbol. Okay, A-like symbol. Okay, L equals A-like symbol times W. Okay, so where L stands for the average number of items in a queuing system. So it is the total. Then the A-like symbol represents the average number of items arriving at system per unit of time. And then times W, so W stands for average waiting time an item spends in a queuing system. Okay, so I have here an example of little law. Okay, so example, Miss Lianza has a coffee shop. So she has a coffee shop. She owns it. She wants to know the average number of customers queuing in her coffee shop. Why? Okay, she wants to know the average number of customers queuing in her coffee shop because so she can decide whether she needs to add more space or not. So she can accommodate more customers in her coffee shop. So currently, he observed that her queuing area can't her queuing area can only accommodate not more than 8 people. So not more than 8 people. So she observed and listed some information. Okay. She observed that there are 40 customers arrive in her coffee shop every hour. So 40 customers every hour. And then on average, each customer spends 6 minutes in her store. So 6 minutes in her store. So she uses a little law so she can find whether she needs to add space or not. So let's apply the L equals the A-like symbol times W. So let's find L. Okay. So A-like symbol times W. In our information, we have 40 customers every hour and 6 minutes spent in every customer. So, in A-like, we have to substitute the 40 customers, which is, like as what I have said earlier, A-like symbol stands for the average number of items that are the people arriving per unit of time. So, there are 40 customers every hour. So, okay, 40, the A-like symbol is substituted as 40 times the W, which is W stands for average amount of time spent in the queuing system. So, it says that 6 minutes. So, we need to make it hour. Okay? So, there are 40 customers every hour. And then 6 minutes spent every customer. So, 6 minutes. So, 6 in 1 hour, there are 60 minutes. So, we have to make it 6 divided by 60. So, the answer will be 0.1 hour. So, now, let's apply the multiplication. L equals 40 times 0.1. Okay, the answer is L equals 4. Okay, so, the answer is 4. So, Miss Lianza, found out that she does not need to create more space in her store to accommodate more customers because there are only 4 customers queuing in her coffee shop. So that's it. And before I end this video, I just wanna give a trivia. That Little Law is by John Little that he developed in 1954. And then not he didn't give a proof. And then 1961 he gave a proof, but it does not hold her proof. And then later on he received recognition in his work for his work in operations research. So that will be all. Thank you.